All right, question number two. Question number two is about proving the statement by the use of contradiction is correct by the help of the contradiction method. Okay, so that's the thing we do in P4, Pure Mathematics 4, and this question says there are two equations, the curve 1 and then the curve 2, and they have a separate different equations and defined for all real numbers, and then we need to use the proof by contradiction to show the C1 and C2 do not intersect. So here is the thing: if you are ever asked to prove something by the contradiction, you have to remember to give a clear assumption. So that assumption is going to be contradict what they say. So they say these two curves do not intersect. We're gonna say assume they do. So let's write here, let's assume they do intersect and have real solutions. Okay, so what we do here is, so they say this do not intersect, like the curves do not intersect, so we assume the opposite. Let's assume they do intersect, and if they do intersect, that means there is a real solution. So if two graphs intersect, it's either a solution or real solutions. I wrote a solution, doesn't matter. So that means they intersect and they have a solution. So if two graphs do intersect, so I can write the case as x to the power of 4 and plus 10x squared plus 8 is going to be equals to 2x squared minus 7. So I can do that because they do intersect. They have a common x point where I put it on the first equation. That's going to give us the same output when I put it on the second equation. So that means this y is equal. So you can imagine it as a simultaneous equation and equalize the y, let's say. Okay, so we need to solve this, and we need to get at the end a real solution, because we said that let's assume they do intersect. And if they do intersect, we are forced to say there is a real solution. Okay. Okay, so we're expecting that's going to give us a solution. Okay, so this is the second step, like the proving the assumption. So we have 3 steps here: assume, proof of the assumption, and then there will be a contradiction what we are assuming here, and we need to write the conclusion for this. But always remember to write where that contradiction appears. That's very important for you to get a full mark. Right now, for the making this assumption, we have 1 mark, and the next 2 marks will come from just basically actually the next 2 marks actually is going to come from the solving and writing the solution and then finding that contradiction, and then 1 mark and 2 marks, and the last mark will be writing a conclusion. So don't forget to write a conclusion. Don't forget to write where the contradiction appears. Okay, so we start solving this equation. Is x to the power of 4 plus 10x squared plus 8 minus 2x squared and plus 7 equals 0, and then that's going to be x to the power of 4 minus 6x squared, and there will be a plus 15 equals 0, and then x squared, and then x squared here. Just thinking, so what 2 numbers I can take, that's product going to give us that's my mistake. It's not 6 here, it is actually a positive 8. So that's my bad. Okay, so it's like a 10x squared and then a negative 2x squared. So the click was 8 on the middle. Okay, so otherwise it doesn't work. Okay, so that's gonna be 3 over here. That's gonna be 5 over here, which is equal to 0, and then x to the power of 4, 5, 3, 8, and then a 15. Okay, so we find that x. Okay, so let me just directly say it from here first. So right now we say the product of 2 numbers, like x squared plus 3 and x squared plus 5 is equal to 0. That's impossible. The reason 3 is always positive and then x squared is always positive. That statement, like this expression x squared plus 3, can be at least 3 whenever x is 0. And the same over here, x squared plus 5 can be at least 5. Always going to be bigger than 5. So this 2 never ever equals to 0. Okay. Or you can say it as, we already know there is no real solution. That's completely opposite to contradiction to our assumption. Or you can say, okay, x squared plus 3 is equal to 0. Then you need to say x squared is equal to negative 3, which is not possible in real number set. Or x squared plus 5 equals to 0, and then the x squared must be negative 5, which is also impossible in the real number set. So, or you can deal with the discriminant, and this you're going to say like there's a hidden quadratic there, discriminant is less than 0, and etc. So we found the contradiction. Contradiction is we do not have a real solution. So what we're going to say here, we're going to be saying, so you can write a perfect contradiction. I'm going to be writing a little quickly, as we're going to be saying, after finding this solution, in the conclusion part, you don't have to write this word a conclusion and then writing like just like this is just the way, just 3 steps. So you're saying at the end, while we complete the solution, proof of assumption, so there is a contradiction to the assumption. What was the assumption for the real number? Like there's intersection and the solution is real. There's a contradiction to assumption, and you're going to be saying which means the C1 and C2 do not intersect. Okay, so the contradiction is you actually can mention this. Contradiction is there is no real solution, or I can also say it right on the top. No real solution. Okay, so we're gonna be done. Okay, so always remember the proof by contradiction. That's only the question in P4. You're going to be C, and then you need to do an assumption. The assumption will contradict what they say. Usually the part then is going to be changing, and prove your assumption. So try to prove your assumption, which you're gonna have a contradiction when you're proving it, and then always gonna have a contradiction, by the way, and then write your conclusion. That's it.